Bismillahir Rahmanir Rahim. In the name of Allah, the most beneficent and the most merciful. Welcome you all again in the virtual learning system of Pakistan International School, Taif, Saudi Arabia. Dear students, as you know that this is Pakistan International School, Taif, virtual class for class 10 students, subject computer science, and today is our 32nd lecture. Teacher name Imran Ahmed. Dear students, as you know that in the previous lecture we were discussing about the construction of logic gates. Same topic, we are going to represent conversion of Boolean function. Example second, conversion of Boolean function f2 is equal to x plus y complement z. So instead of solving this one, already it is solved on the book in the examples. So example 3 is also, so we will focus on the questions. Question answer is also present in the exercise. So we will convert the next question answer of same topic in the exercise. Method, although method is same for the construction, so no need to worry about it. The examples are left because construction of the gate is same as we have done, as we will do in the exercise. Next topic is simplification of Boolean function using Karnaugh map. So this topic is beyond your course, although it is present in the book, but according to the reduced syllabus, only 6 point till the 6.2 is included simplification of Boolean function using Karnaugh map or K map is not included. So we are going to skip this topic and we will check the what the next topic is present in our course. So all of this is about to the Karnaugh map. Now the exercise. This was the Karnaugh map was the last topic exercise. Select the best answer of the following MCQs. Which operation is represented by the plus sign? So or is represented. B option is correct. Or is used for the plus sign. Which operation is represented by a dot or absence of an operator? If there is no, let's say x, y, z, it means that they are multiplying, or the dot will be x dot y dot z. So and operation, A option is correct. Next one, which of the following gate is known, gate is also known as inverter? So inverter means complement. So NOT gate is used. Option D is correct for this purpose, for this MCQs. Next one, which combination of inputs to input gate, which combination of inputs to a two inputs AND gate, watch here, focus on the AND gate, will produce output high? It means that 1 and 1 result will be 1. So high and high result will be high. So option C is correct in this case. Question number MCQ number 5. Which logic gate is represented by the function x plus y whole complement? First of all, we will check x plus y is OR gate. Now inverter is over there, so x it is NOR gate. So in the NOR gate, not or NOR gate is B option. Next one, each logic gate is represented by the function is equal to x y whole complement. So first of all, we will check x y is AND gate, x dot y representing the AND gate, and complement making this AND into NAND gate. So option A is correct. Over here, option A is the correct one. Next question, next MCQ. What is the maximum number of possible input combination to the truth table that has three variable? So that has three variable, 2 raised to power 3. So the possible inputs for the variable in three variable in the truth table is 8. So option C is correct. How many AND gates are required to create the logic circuits of the Boolean function? So we will check. Number one is over here, one AND gate, two, and three AND gates are there. Three AND gates. We are going to use the three AND gates in this. So option C is the correct one. Short question. What is logic gate? When we are describing the chapter, already we have solved define truth table. Already we have solved define the Boolean function. Our previous topic was about the Boolean function. What is Karnaugh map and why it is used? K map or Karnaugh map is out of your course. Draw three variable Karnaugh map. This one is also out of the course. Draw in graphical symbols of and or not, NAND and NOR. In the previous lecture, we have already drawn the and or not, NAND, NOR. Although we are also explain the exclusive or exclusive NOR, also we have represent. Explain how NAND and NOR gates can be created using and or and not. Already we have done in the chapter explanation. Now this one, draw the truth table for the following Boolean function. Now we are going to draw the truth table for this function. First function is f1 is equal to x complement yz complement plus x complement yz plus xyz complement. So over here, there are all of these are the same. We will do the first and the third if you want. If you use a according to me, the fourth is little bit okay. We will check which one is the u. Now first function is draw truth table for the following Boolean function. First is f1 is equal to x complement. Over here in the computer, as you know that the bar x bar y and z bar represent the complement plus x complement yz plus x y z complement. So how many variables are there? There are three variables. One is x, another y, another one is z variable. X complement and y complement and z complements are the same variable, but the inverter of the simple variable. So in this equation, in this function, we have three variables x, y, and z. There are three variables. So I told you for the three variables, how many inputs will be there? There should be 2 raised to power 3, 8 input. Watch here in the input column, 0 to 7, there are 8 input. Now to construct the truth table for the three, first of all, the first step over here to construct the truth table for the three variable. In the previous lecture, I told you how to construct the truth table for the three variables 0, 0, 0, 0, 0, 1, 0, 1, 0. How we represent this 0, 0, 1? We are going to equalize the input to the weight. For example, 5 is over here. Watch here. 5 is here. And the 5 is the 101. Why 101? Because 4 bit, x is 4 and z is 1. So which bits are used? X is used and z is used. So 1, y was not used. So instead of y, we write the 0 and x and the z are equal to 1. So all of the inputs are look like this 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. 100 101 110 for the input, last input 7111. Why 1? Because 4 plus 2 6 and plus 1, all three bits are used, so 111. Now first of all we will take the complement. Watch here in the function x complement. X complement is, where is the x? So this is the input of x. So x complement, where is the 0? I will replace the 0 with the 1. And where is 1? I will replace with the 0. Watch here. 0 is when replaced with the x complement is 1. And this 0 will replace 1. 0 is replaced with the 1. 0 replaced with the 1. And 1 will replace with the 0. And this one, because we are going to take the complement of x, so it should be look like this 1 1 1 1 0 0 0 0. So next one is check over here, either y complement is there in the equation. There is no y complement because x complement y z complement, x complement y z, x y z. So there is no complement on the y, so no need to take the y complement. Next, z complement is there, so now I am going to take the complement on the z. Watch here. The input of z are these. This is the input of z. So when I will put the complement on the z, so 0 will be replaced to 1. Watch here, 0 is replacing with the 1 and 1 will be replacing in the with the 0. So 0 replaced with the 1. So all of the z complement should be like this one. Now we have all of these possible combination. Now first operation is x complement y z complement. I will take x, this one, y, this one. Sorry, x complement is over here, y is over here, and z complement is over here. X complement 1. So between all of these operation, check here, there is AND operation. There are AND operation between them. So x complement y z complement, x complement y z complement, 1 0 0 1 0 1, result should be 0. Why result should be 0? Because in AND case all the input should be 1, high and high. So all the, when all input should be high, then we will achieve the result high. So watch here again, 1 the equation is look like this, x complement y z complement for the second input, x complement over here, y over here, and z complement over here. So 1 0 0, so 0 is present over here instead of 0 is over here. So when the input becomes the 0 in the end, so result will be low or the 0. Now in this case, x complement is 1, y is 1, and z complement is 1. 1, 1 and 1, result will be 1 because all the inputs are high, z complement is high, x complement is high, and y is also high. So when all the input becomes high, so result will be high. Rest check over here. Over here there is 0, so no need to check. 0 will be the output. In this case, all of this becomes rest. The all of become will be 0. Next, same process for the x complement yz. Now I will check x complement y and z. X complement y and z. Over here z is 0, so 0 0, check over here. Why this one is 1? Because x complement is 1, y is 1, and z is 1. When the all input becomes high, so the result will be high, so rest all will be 0. Third operation was, third equation, x y z complement. X y and z complement is over here, so I will check all of this because in the x first 4 is 0, so no need to check. First 4 should be, first 4 will be 0. Next, where is the 1? 1 is over here, x y z complement. So x is 1, y is 1, and z complement is 1. When all input becomes high, the result will be high and the rest will be, so all of this one input is over there in one case. Now we have x complement y z complement plus x complement y z plus x y z complement. All of these three having the OR operation. Watch here, plus representing the OR operation. So we will use F1. This one is equal to F1. In the, I will check these three now. The output of these three now will be the our function. Check over here, 0, all of there is 0, so result is 0 in the F1, and these are the 0 0. Now in case of OR operation, if any input will be 1, so result will be 1. Over here there is 1, so 1 is over here, there is no 1 is over here, so result is 0. So again over 0, again check over here also is 0. So this one is also becomes the 0. So this one is the first function. Now second question is the same like this one, and I will going to solve the last part of this question. Last part was over here. First of all, in order to construct the truth table, you must know how many variables are used. Watch here, xz complement plus x complement y complement. So there are three variables. Why three variables? One is x, another one is y, another one is z. The same truth table for the three variables x, y, and z is same truth table over here. Now, first in the first step, we will check where the complement is applied. And the okay, first of all, yes, x complement is present. So we are going to the x complement and we replace the 0 with the 1 in the x and 1 with the 0. Y complement is also there. So in the y complement, we will represent the 0 with the 1, and watch here, there was the 0, 0. So instead of 0, 0, when the y complement, it will be 1, 1. So rest all will be the same process. In third one, z complement, instead of 0, again we are converting the 0 into 1 and 1 into the 0 for the. Now first step is over here xz complement, and between xz complement there is AND operation. So xz complement, I will take x over here and z complement over here. So these two input will be used 0 and 1 result will be 0. 0 and 0 result will be 0. 0 and 1 result will be 0. 0 and 1 0 result will be 0. Now watch here. 1 and 1 result will be 1. There is 1 in the x, and in the z complement there is 1. So xz complement over here, the result will be 1. Rest check over here, 1 and 1. So there was the only, I think, two inputs are there which producing the one output are high. Now the in the second part, x complement, y complement. X complement, y complement. So x complement is over here and y complement is over here. We will check 1 and 1 result will be 1. 1 and 1 result will be 1. 1 and 0 result will be 0. So where there is, in case of AND operation, any input will be 0. So the rest will be 0. Now for the x complement, y complement is this one is the output. So F4 function, y x4 function is x complement. So addition of these two, we have solved this one, xz complement. Already we have solved x complement, y complement. Between these two, there is a operation, OR operation is there. So we will perform the OR operation between these two in case of OR. So these are two performing the OR operation. When any input will be 1, so we will place the 1 input over here. So 0 or 1, 1, 0 or 1, or again output is 1, 0 or 0, 0. So watch here, 1 or 0, again 1. So where there is 1, so you will place the 1 input. So this one is the truth table, making how to make the truth table. Whenever you have the three variable, keep in mind for the three variable you have 8 inputs, but you will must start from the 0. When you have start from the 0, it will goes up to 7. So 0 to 7, there are 8 inputs. For the three variable input, the truth table is over here. Next question, you simplify the Boolean function of the Karnaugh map. Let me check over in the exercise. Simplify the Boolean function, draw the logic circle. A Boolean function using question for using Karnaugh map. So K map is not included in your course. So skip the question number 6. Draw the logic circuits of the following Boolean function. So we have the Boolean function. Now we are going to the logic circuit using the AND, OR, and NOT gate. With the help of AND or NOT gate, we can construct the easily logic circuits. This question is skipped. Now this one. Draw the logic circuits of the following Boolean function. Boolean function is this one: x complement, y complement, and z plus x, y complement, z. So watch here, x, there is x complement. When the x will be passed from here, so x complement will be achieved. When the y will be passed over here, so y complement, when the y will be passed from the NOT gate, so it will give me y complement. Z is simple, so no need to pass the Z from the NOT gate. So watch here, the Z is going from there and till over here. Now this AND gate, first AND gate, top AND gate, having the three inputs, which is x complement, y complement, and z. So when the three input will be passed from the AND gate, it will give me x complement, y complement, z. Second equation is x, y complement, z. So x is coming from that spot, x is coming over here, y is y complement. So I will take the y complement from the over here, from after the NOT gate, now second NOT gate, y, and z is coming over here. Z is straight, so there is no need to. So all of these three, x, y complement, is z is passing from the AND gate. When they pass from the AND gate, they will give me the this output for this one, x, y complement, z. Now watch here. Between these two, x complement, y complement, z plus x, y complement, z, they having the OR operation. This is the OR operation, and we are going to use the OR operation, and it will give me the function f1 is equal to x, whatever the function. Second one is easy to draw the logic gate: x complement plus yz. Same three variable, x is over here, no need to worry about the x is at the top, and so you can place x over here, you can place y over here, you can place z anywhere in the input. X is over here and y is over here. I will start z, y, x. So first operation, you can perform the x complement. When the x will be passed from the NOT gate, it will give me the x complement over here. Now the second is yz. Yz, when passed from this AND gate, it will give me the yz. So the x complement plus y, that's when the x complement and yz will be passed from the OR gate, it will give me the second function. For the third one, same process. For the third one, x, this is your assignment to draw yourself and try to make the basic gates which are the AND, OR, and NOT, so you can implement the circuit as given over here. Last question is last part of the function f4 is equal to x plus y complement plus yz complement. To construct the logic circuit for this function x plus y complement plus yz complement, there are three variables, binary variables are involved: x, y, and z. Now where the complement, there is a x is straight, that's why x is coming from over here and it is directly with the OR operation. But first of all, we will convert the y. So when the y will be passed from the NOT gate, it will give me y complement. So third one is yz complement. So y is over here and z complement, when the z will pass from the NOT, it will give me the z complement. Now y and z complement when passing from the AND gate, it will give me yz complement. Now the equation is like this: x plus y complement plus yz complement. X is coming from that side there, and y is coming from the here, and yz coming from the here, and all of these three having the OR operation. So they will pass from the OR gate, and they will give me the function f4, which is f4 is equal to x plus y complement plus yz complement. I hope you understand this topic. This is very easy, but they need the practice to do. So you will try to make the practice. Your course is complete over here because chapter number 7 is fully excluded from the course. Inshallah, I hope you will practice and you will do the much programs as better in the C language. uh, Whenever you have the practice, the concept of the programming will be clear. Take care of yourself. Pray for me. Pray for all Muslims. Allah Hafiz.